For this lab, we looked at direct air capture of carbon dioxide by reacting it with calcium chloride in water to form calcium carbonate. Our plan was to measure the mass of solid produced at different pH values over time to find how the rate of carbon dioxide removal changes with pH.
Why are we doing carbon capturing in the first place? One of the most pressing environmental issues of the 21st century is global warming. Global warming is caused by the accumulation of greenhouse gases such as carbon dioxide. The current atmospheric level of CO2 is 400 parts per million and is expected to keep increasing. This increase in atmospheric carbon dioxide is responsible for about 2/3 of the total energy imbalance that causes our Earth's temperatures to rise. Carbon dioxide can also be harmful to marine life by increasing the pH of our oceans.
For this experiment, we used starting pH of 8, 10, and 12, and measured the rate at which CO2 was captured over an 8-hour period.
Our reactor was set up to be filled with 800 milliliters of water, set at our desired pH, which we measured using a pH probe. We then placed 2 air stones in the reactor to constantly supply carbon dioxide from the air. The reactor was stirred continuously to ensure a well-mixed solution. Finally, we added our desired amount of calcium chloride to begin the experiment.
In increments of 2 hours, we'd come into the lab and take a sample of solution from the reactor and filter it to remove any calcium carbonate that precipitated. After drying the filter paper overnight with a desiccator, we'd then measure the mass of the calcium carbonate on the filter paper and scale it up to find our estimated mass of calcium carbonate in the reactor. This helps us determine the mass of carbon dioxide our reactor removed over that period of time.
We were initially expecting to measure the change over time for each reaction, but the values stagnated after 2 hours, implying that the reaction stops occurring before 2 hours. The pH of 12 by far gave the most calcium carbonate despite starting with the least amount of calcium chloride. This shows that the reaction is far more favorable at extremely high pH values.